I'm Bartek. I'm a programmer. I don't do mobile programming, apart from websites. But I do Ruby. I started with frontend, and right now I work at Codebeat. Codebeat is an automated code review tool. So basically, we want to help people to make better code. There is plenty of solutions like that for Ruby, and for JavaScript, and for PHP, and for Java, but there aren't any for iOS. So that's where we focus, and that's why I'm here. We do automated code review for Swift, and there will be automated code review for Objective-C soon. So yeah, it's a website. You sign up, you link up your GitHub repo or Bitbucket repo, and we analyze your code. And I'm going to show you how it looks. So I selected Alamo Fire. This is open source HTTP library for in Swift, very popular. And I've added it to Codebeat. Anyone can do it if they sign up for an account. You just enter public URL. And what we do is we analyze the code. Here you can see the quick wins for Alamo Fire, which are the worst offenses in their code quality. I will reiterate over what those are later. We do track changes over time. So here you can see how they added new namespaces or classes and what grade they have. Also, we have a GPA, which you can see up top, which is from 0 to 4, and it's how good your code is. And there is a badge that you can add to your README like other similar services. Also, we have a list of all namespaces sorted with worst classes first, so that you know where you have to start to fix your code to make us happy and make yourself happy. And yeah, when you click on one namespace, you can see exactly what is wrong with it. And out here, you can see issues. And code issues are basically like F is a grade for the class, and that means that it's F in bad, but you see issues. And issues mean exactly what is wrong and where. And we have several types of issues, which I will showcase later. Also, we group them. There are complexity issues and there are duplication issues. We have a page with a code preview with highlighted places with issues, and we have a changelog, which is shows how code changed over time in our analysis. So let's go through issues we catch with examples in Swift. I don't know Swift personally, but I was able to understand the examples I created, which is good, and I hope you will understand too. First thing is we calculate cyclomatic complexity. This is the amount of possible paths through code. So right here we have a function from Alamo Fire, and we see I have highlighted case statements and ifs. And basically every case statement means if code flows through there is a different path. So those three circles up top, they represent case statements. And the triangles below them represent ifs. And what cyclomatic complexity does, it computes the overall score for the more paths there are, the bigger the score is. We also calculate ABC, which is assignment branch condition. It's also a number, and the bigger it is, the more complicated the function is. And you want your functions to be simple, because simple functions are better and easier to understand, and easier to refactor, and easier to move. So we have the same function. It's a pretty bad function. And we can see here that it's, well, first of all, we can see up top it's ABC is 13, which is, it's not that bad. That's why the circle next to assignment is I think it's green. I don't see color. But I think it's green, and that means it's not a bad issue, but it's an issue. So what we do is we count assignments. So I highlighted all assignments, and we count branches, where branches are, when you send a message to a different object, therefore hiding complexity from the method. So a method that calls a lot of different methods on different objects might be simple, but in fact it's complicated because everything is happening in all those other objects. And we have conditions like in Cyclo, and we take the three counts, we square them, add them, and root them, and that's the ABC count. So if your methods have high ABC counts, then they are bad methods, but it can be worse. If your class has high ABC counts, you basically are like that. Another issue we collect is arity, so that's the amount of arguments passed to a function. That's pretty simple. The less arguments, the simpler the function is. And so we have an example again from Alamo Fire. We have 6 function arguments, and that means that the method is too complicated. We also penalize block nesting. So basically, nesting is indentation of code, which is visual, but we don't treat it visually. We count blocks or closures that are opened, and each next closure is another nesting level, and the more nesting level, the more difficult it is to understand what code does. And yeah, the easier the better, right? We also count lines of code. That's super simple, and that's not we don't penalize heavily for lines of code because it's fairly trivial. The longer a method or entire namespace, then it lowers your score, basically. We also count methods in namespace. That's pretty similar to lines of code, but you can have lots of lines of code and few methods, and you can have many methods that are one line and very wide. So it's also shows that the class is too long. Anyway, the best thing we do, in my opinion, is finding out similarities. So we take your entire code base and we find places where there are duplications. Now, I hope I don't have to tell you why duplications are bad, but they are pretty bad for refactoring reasons. So when you want to change something, you have to change it in multiple places. Also, when you want to just change something, change the behavior of a certain part of your app, if it's duplicated, then you can introduce bugs. And what we do is we run through entire code base and we find identical code in all files. It can be in the same file, it can be in different files. And we highlight the lines and we show the snippets of the same code. And it doesn't have to be identical. We accept some difference. So here is an example of similar code, and we can see that the string that's assigned to failure reason and the code that's passed in is actually different. But other than that, those two parts of code those two snippets are identical, so it should be abstracted out to a method. And when you have duplication, the Pikachu is sad and Batman is sad. So that's bad when Batman is sad. Last issue type we have is instance variables. So basically, when you have a class and it has too many instance variables, that means it has too many responsibilities. And it's advisable to refactor it into 2 more specialized classes for future understanding and for future reusability. And it looks like this. So it just shows too many instance variables. So those are our issues. The important thing is when you I hope everybody will put their code in Codebeat and see what score they get. It's free for open source repos, and we have a 14-day free trial for private repos. And the important thing is it's very, very strict and very, very, the limits we have are very low for the scores above which we highlight issues, but everything can be configured. You can exclude files from analysis, you can change your thresholds, or you can exclude a single function, because you might have reasons. You know your code the best, and we don't know it. We are learning on our client's code, basically. And you can read more about our metrics at help.codebeat.co. There is a lot of content there, which is really cool. And Yoda writes for us also. And The things that are really exciting for us are the things that are coming. The biggest thing is coming soon. We will have pull request integration, like CodeShip, for instance, that runs your tests for you. So we will be running our checks. Currently, only we have access because we are testing it out. And when you click on the details link, you will see a report for this particular pull request. And you will see that, that's a coincidence that everything has improved in this one. That's not planned at all. But you will see that if the changes you want to merge into master or whatever the default branch is, if they are bad for your code or good, or how the grades have changed, we will be showing detailed issues. Right now, you can only see the diff between what you've added, what created the change we are highlighting. But if someone wants to have beta access, they can hit me up later and I will make it happen. And also we have as part of project in our app, we have a page where we list all pull requests that are open and some recent closed ones. So yeah, and when pull requests come out, they will be integrated with Slack and with email on opt-in basis. So you can select if you want to receive emails, or someone who administrates the Slack, your Slack account, they can add notifications, and notifications are great. They look like this. It's super fast. For our significant Ruby front-end repository, it takes a few seconds to come up with diff analysis with newest stuff. And we will have, as I said earlier, Objective-C to cover the neglected iOS area of DevTools. So I wanted to say a few words about how it all works, because it's pretty complicated. And we have hamsters and fans and balloons. And so the web app is a simple Rails app with front end written in Marionette.js. There is nothing special there, but when we do our analysis is where we party. And yeah, to run our analysis, we have to have Python, Go, Ruby, and Java. And yeah, so anyone who has set up a project before that's not with iOS projects, I heard it's pretty bad as well, but with web projects, if you set up your project locally, usually it's a pain in the ass. So with 4 languages to support, that would have been brutal. So we use Docker. And Docker is a containerization engine. So basically, we create images with all the dependencies we need. And then we reuse those images across both development machines and production machines. So we have the same code running when we work locally and that we deploy to production. And that's super simple. I encourage anyone to play with Docker because it solves all problems, basically. And so we have front end in Ruby and we have back end on Docker in all those languages, but how do they communicate? They use RabbitMQ, which is a queuing service. So when you add your project, the front end will queue up an analysis for you, and back end is listening for new analysis. And once it gets one analysis, then it will analyze it and put into a different queue information for a front end that analysis is ready. And then front end is listening on that, and then it will parse it into web-friendly content. So are there any questions? Well, the question is, Swift is moving quickly, and it's not really backwards compatible as well. And how are we handling that? The truth is we aren't. We fight the same fight everyone is. Right now, we do our best to support the latest version of Swift, but we are aware of that. And once it becomes significant, we will look into ways to support different versions of Swift per project. However, for if statements, I don't think we will. It's probably a good case for exclusion. So you can put a magic comment in, and that section of code will not be analyzed. So you can select disable Swift 2-bit and only keep Swift 3-bit in, or whatever. But we don't really have a good plan for it because Apple seems to not have a good plan for backwards compatibility and releases, and also documentation is incomplete at times. So Any other questions?
When Objective-C is available, will you support mixed projects?
So the question is, when Objective-C is available, do we support mixed projects? Actually, you don't specify language. When you add your repo, we analyze anything that we can out of it. So we will support mixed projects. We support them right now. Any other questions? Okay, thank you.